Bismillahirrahmanirrahim. Welcome back to my channel. Back with a video on software-defined radio, and we're gonna look at a video, and we're gonna learn how to actually generate amplitude shift keying using GnuRadio, and we're gonna learn how to demodulate this signal. Right. So I think the previous video that I have made on this is where I was using amplitude shift keying to transmit a signal from Pluto SDR and try to receive it using RTL SDR dongle or something like that, or XRF. Then this video, we're going to generate a signal. We're going to transmit that signal, of course, and then we're going to try to receive that signal. We're going to try to demodulate the signal using the same flow graph. So when you think of any modulation, you're immediately thinking of something, my intelligence signal or my information signal, my modulating signal is being multiplied together with some carrier signal. This is what comes into our mind, and this is exactly what we're doing here. So let's just quickly go over this flow graph and let's look at it. Let's look at the output of this flow graph. So as you can clearly see, we have a vector source right here. This is sort of like generating zeros and ones for us. So right now it has 0 1 0 1. You can choose this to be any data stream that you want, any values of 0 1s. So this is 0 1 0 0 1 0 1 1 0 0 1, so on. It's going into a throttle block. Definitely, if you don't have a physical device connected to it, you gotta have a throttle block. And then there is an interpolation block, or sort of like a repeat block. This repeat block which continuously transmit that data. It will continuously repeat these packets again and again and again and again. And I have chosen this value to be 320. Why 320? The more sample, the more repeat sample you will have, the better your output is going to be when you're looking at it, your modulating signal, or either when you're looking at an output when you're demodulating it. So that's why in GnuRadio. And the reason I've chosen this to be 320, why? Because I've chosen a target rate which is 32 mega samples, and I have a duration. I could have just simply typed in 300 samples. It doesn't matter. I'm just showing you this is another way of doing it. So you have a symbol duration. A time will take for an entire symbol to transmit or to move is 10 microseconds times the target rate, which is about 32 million samples. So that 32 million times 10 microsecond would give me around 320. So 320 mega, 32 mega times 10 microsecond would give me 320 samples. So it's going into a multiply block. So you have this vector source which is giving me zeros and ones and is being repeated 320 times. It's going into a multiply block. This signal is being multiplied together by a cosine signal that has an amplitude of 1 and a frequency of 1 million. You're also visualize. So this is sort of, I'm calling this as an input, and the output of my modulated signal is being called a modulated signal, which you can display using your GUI time sync. Now, this thing is going in, the output of this signal, if you remember it, for amplitude modulation full carrier, you will have a rectifier circuit, isn't it? You have a rectifier or a diode in physical form. It's actually a diode. So this is actually a rectifier block. Which was, you can just simply grab a Python block from here, and you can program this to act as anything you want in a flow graph. So this is an example of that. So let me just simply go in. So this rectifier block, what it's doing, it has two parameters. It has a gain parameter, it has a threshold parameter. So you can go into an open netted block. So based on two values of your threshold value, either is -1 or +1. So this is the code that was written for this rectifier. If it's following those threshold value, you will get your signal. You will get the top part of your signal. If it's not following that signal, you will not get any signal. So basically, it's acting as a rectifier circuit. So this is basically a flow graph. A block for that. So a threshold is 1, gain is 1, and threshold value is set to be 0. So it's between -1 and +1 basically. That's what you're looking at. Now this block, so after this, the output of this is going into a low pass filter block. So this is also a very crude design, which was designed using a Python block, which is available in GnuRadio. So this low pass filter is also another block in Python using Python. It has two values. You have your cutoff frequency, which is given as 1 mega, 1, 2, 3, 100,000 divided by 2, that would give you 50K. And this is just going to be your sample rate, which is going to be your sample frequency. This is also designed using a Python block. All right, and you are seeing the output from that rectifier is going into this low pass filter, and you're seeing the output here. And then, just to show you the functionality of the filters that are available to us, so the same output is going into a low pass filter block that is available in GnuRadio, which is a built-in block that has much more parameter as compared to the low pass filter block that I designed and that you can design using a Python block. So decimation is still 1, gain is 1. You have a cutoff frequency that is 50K, and you have a transition width of 100. Plus you have some windowing function that also helps. So that is Hamming window. And I'm calling this as an exact output. So that's the basic idea regarding amplitude shift keying, where I'll be modulating my signal using a 1 megahertz of frequency. That signal is being transmitted. This is what I'm calling a modulated signal. And this modulated signal, so this sort of basically rectifier sort of acting as a receiver circuit. Your signal is being received, you're going through a low pass filter, and you're looking at the output. So let's just quickly run this flow graph quickly, and let's actually look at it, what's going on. So when I run this flow graph, all right, so as you can clearly see, this is the output. This is the output from this filter, all right? And this is the output, which looks a lot like our actual signal, which is this, which is coming through this particular filter. So having that said, let's just look at it. First of all, let's look at our input. So let me just simply go to control panel. And let me do this. Let me select the Y range. All right, let me stop this. So we have a lot of 0, 1s and coming in. So let's just quickly go through this again. So we have 0, 1, 0, 0. So I'm gonna assume we have 0, 1, 0, 0. Then we have 1, 0, 1, 1. Do I have 1, 0, 1, 1? 1, 0, 1, 1, and then 0, 1. So this is being continuously being repeated. So exactly this is what is being generated. I can clearly see this from my vector source. So 0, 1, 0, 0, 0, 1, 0, 1, 1. And you can clearly see this by stopping this. So by using your mouse button, you can just simply stop this. So this is this. And now this is my modulated output. So I can simply do this. Let me just get the control panel. Let me go here and let me do this. Here we go. And let me stop this. So this should exactly replicate my output like this. Whenever I have two highs, you can clearly see I have my signal present. Whenever I have zero, there's no signal present. Now you can clearly see this. This is exactly being mapped here. So this is actually this signal where you have two highs, then you have low, then you have high, which is representing this, then you have low, which is this, then you have high, and then you have two lows. So this is exactly the same thing. So this signal is being modulated. Your signal is present in ASK amplitude shift keying. You have your carrier signal, which is present, and at 0 you have no carrier signal present. So at least this is good enough. Now this is the output that you're looking at without any fancy filtering. This is just a plain old filter where you have a signal that is passing through a filter that has a cutoff frequency, nothing else. This is that output. So let's just quickly do the same thing. Let's call in our control panel, and let me do this, and let me do the Y's. So the output should exactly look like this. All right, this is what we are after, basically after demodulation. So as you can clearly see, this is somewhere there, but you can see a lot of noise. This is exact output. We're using a much better filter, low pass filter definition here. So let me do exactly the same thing. Let's call in our control panel and let's do some y-axis. Let me just shrink this down. Sorry, I have to do it like this. Here we go. Now let me stop this. This is a much better representation of my original signal, which was transmitted using amplitude shift keying. And right here. So if this is being modulated, so I have, okay, let's pick up this. You have two ones, which is this, followed by a 0, followed by a 1, followed by a 0, followed by a 1. Then you have two zeros here, then 1, then 0, then two ones, then 0, and so on. This is much better representation of my signal as compared to this. Let me stop this. So if you were to compare this with this, so this is the exact output. This is the representation of my modulated signal, which is being modulated here, and this is my input signal. So I hope you like this small tutorial on this, much detailed version of it. If you have any question, leave it in the comment section. Please don't forget to like and subscribe to my channel, and thanks for watching.